Okay, so polynomial functions, ladies and gentlemen, are basically just higher degree polynomials bigger than 2. So in other words, it's solving something like this. Let's say that f of x was equal to x cubed minus 4x squared plus 5, something like this. And you would be able to solve it and be able to work it across till x equals certain numbers. Okay? Alright, so there's a couple of different ways of doing this and just working with this. You have to remember back to Algebra 2, your rational root theorem, all that stuff. I'm going to show you the shortcut. And it's not in GeoGebra. Come on, Desmos. Okay, so my original function was x cubed minus 4x squared plus 5. Okay, so where do I start? So how do I start this bad boy? I start by graphing it. So go x cubed minus 4x squared plus 5. Okay, so it looks something like this. Oh, come on. Okay, so what I would do is I would identify, okay, this is going to have 3 real roots. Alright, now I'm going to be honest, to finish off this problem, I'm probably going to use this -1 with my synthetic division. Okay, so I'd use -1. So the -1 right there, and then I write out my synthetic division, -4. Remember, you're going to have a 0 as a placeholder for the x, and then 5 right here. Okay, so we have the 1 right there, times it by -1, so we get -1. So this becomes -5. Okay, times that by -1, this becomes 5. Add it, we get 5. Times it by the -1, we get -5, and so we get 0. So we know we were going to get that because of the rational root theorem. Okay, so now what my polynomial is going to look like is it's going to look like x plus 1 parentheses x squared minus 5x plus 5. Okay, so we have it all set up like that. So we have the first part all set up. All right, now the second part we can't factor, and if you remember from our graph over here, we were getting some funky numbers. So that's going to suggest that we are going to use quadratic formula. So the quadratic formula is going to set it up as 5 plus or minus, and I'll 241, plus or minus the square root, I'll 251, of 25 minus parentheses 4 times 1 times 5. Okay, so I have this all set up like this. Okay, and then on the bottom I'm going to have 2 times 1, which is 2. So just setting up my quadratic formula, I get 5 alt 241 plus or minus. Now this right here is going to turn into 25 minus 20, which turns into just 5. So that's the square root of 5. So I'm going to have alt 251 5 over 2. And so those are going to be my two answers. Okay, so in actuality, my answers for this are going to be actually 5 plus or minus root 5 over 2, comma 1. -1, sorry. Those are my two x values that are solution for this. So I actually have it all set up. There we go. Okay, now if you are given some points to actually determine a solution, like let's say the roots are -2, 3, 0, and 5, okay, how do we actually find the polynomial function? Well, you set it back up by doing the reverse. So x plus 2, x minus 3, x minus 0 and x minus 5. Okay, and then you just multiply out, and so this first one you should get x squared minus x minus 6, and this other one you should get x squared minus 5x. Okay, and if you guys remember, x minus 0 is just x, so this just turns into x. So that's just a simple distribution part. But then you're going to have to distribute there, and you should get x to the 4th minus x cubed minus 6x squared minus 5x cubed plus 5x squared plus 30x. Okay, and then we just combine like terms. So these two are going to make negative 6x cubed. This is going to be negative 1x cubed. So this one's actually going to be pretty cool. X to the 4th minus 6x cubed minus x squared plus 30x. Okay, and that's going to be your actual function. So this is going to be equal to f of x. Okay, so it's going to be set up like that. So you can go the reverse, you can find the roots, you can go back from the roots and find the actual function. That's the main thing you need to do in this section. Okay? All right, thank you guys. Have a great day. Bye.